Hi everyone, welcome back to Nelson's channel. So today we're going to see how to build a mini moving head that's fully programmable. Of course, we'll also see how to program it with a simple Arduino Uno board. But before we continue, make sure to subscribe. Come here. That way, you'll see what this moving head will be used for, since I'm building an entire miniature stage in my living room. I'd say let's start with the materials needed for this build. First of all, guys, you need a 3D printer, because without a 3D printer, we can't make all the components we need. You'll find the link to download all these files down below in the description. Let's start with the base, in fact. This is the base of our mini moving head, where we're going to fit a servo motor right here, but we'll see that during the build. On top of this small base, we'll mount the arm that basically acts as the yaw, as if it were an FPV drone. Next, we have the central body of our moving head, which is made up of two of these pieces, one of which is printed as a mirror image of the other, and once joined together, they form the body of our moving head. We also need to print one of these things here. This part is used to fit the head inside and create a sort of light cone. After that, I recommend printing, for example, two beams like these. I printed two beams just to stick with the stage and party theme. Alright, that's it for the 3D printed parts, but we'll need some electrical components as well. And starting with the two servo motors, these are the classic SG90S. Be careful, you need 180-degree servo motors, not 360-degree. We'll need two of these, one to move the yoke and one to move the moving head. If you can get the all-metal SG90S, that's even better. They cost about 50 cents more each and they never break. These ones are very fragile. Next, we'll need an LED in the color of your choice. I'm using this red one, and a 220 ohm resistor. Of course, we're talking about a power supply that's entirely 5 volts. After that, you'll need any Arduino board. In my case, I'm using this one, an Arduino Uno, a Chinese clone. A standard breadboard to make all the various connections and tests, a whole set of wires and jumpers, and then we'll need something to provide an external 5-volt power supply to our system. In any of the Arduino kits, you'll find linked below in the description. You'll also get this little gadget here. I'm going to mount this little gadget here at the positive and negative rails, and with a simple USB to USB cable and an additional power bank, I'll simply power my entire breadboard with an external 5-volt supply. Alright guys, I'd say it's time to start the build. First of all, get yourself some sandpaper. And at this point, let's take the first servo motor and one of the two parts of our body. Let's check how it should be inserted. In this case, it needs to go in like this, but we have to remove this tab because it's really getting on my nerves. There we go. Now guys, we need to work on the LED. Before we go ahead and remove this part here, I also want to show you how to mount the servo motor inside the base. In this case too, we'll need to remove both tabs so that we can fit our servo motor into the base like this. Let's have it stick out enough. As we can see, it's raised above the surface. And on top of this, we'll later mount the little arm that controls the eye. Let's do a quick test, also closing the upper part of the body. One small modification we absolutely need to make is to cut this connector so we can pass it through our arm, bringing the cables with me. And there you have it. Basically, our movable head is assembled. So guys, I'm going to do a couple of soldering so I can also mount the LED, and I'll see you in a second with the whole structure ready. And here we are back guys. So I want to show you what I've done. Basically, I mounted the LED with its resistor hidden there. Once that's done guys, let's tuck the cables in nicely and close up our main body. Here I used a drop of glue to secure the little drum that holds the LED. Let's run all the wires through the arm, bring everything out down here, and then proceed to fit in our servo motor. Press it in well and close it up. And here it is guys, our little moving head. At this point, all that's left is to connect all the various wires to the Arduino board and to the external power supply. First of all, let's start with our power supply, using this little board that comes with the kit to provide power to our circuit completely externally. Let's connect our Arduino Uno board and start powering it as well. As a result, we have a 5-volt positive going to the VIN pin of the Arduino Uno, and we connect the GND to the white GNP pin. Now, as for the controls from our Arduino, we basically need to control three things: servo motor 1, servo motor 2, and the red light. We will use pin number 9 and pin number 11 to control respectively the lower servo motor and the servo motor inside the body. So servo motor 1 will go to pin number 11, pin number 9 for the second servo motor, and the LED to pin number 6. At this point, all that's left is to make all the power connections. You just need to make sure that the ground of our servo motors and Arduino are connected together. Alright guys, that's everything that needs to be connected. In theory, there's already a program on our Arduino Uno board, so once you power it up, it should move and do something. I'll grab the power bank, put the other thing in here and turn it on. Apparently, in the program that was written in here, I got the pin numbers wrong. But that's not a problem at all, because now we're going to write the program from scratch anyway. Meanwhile, for convenience, I'll make a small base with 2 of these. Here we are again, guys. Now let's start programming our moving head using the very simple Arduino book. We'll basically do it with a blank screen, so we'll create the sketch from scratch so that as we build it, we also understand what we're doing. First of all, you need to include the servo.h library. Then, still before the main void setup function, we absolutely need to meticulously create our essential objects. Now let's proceed to carefully create the setup function itself. And right here in the very middle of this section, we will precisely insert our servo motors. For example, we can write servo1.attach, and within the parentheses, we will clearly specify the particular pin is physically connected to on the microcontroller board. We do the same thing for servo number 2.attach, and in this case we put 11. And up here I made a mistake. It's not pin 6 but pin 9, because pin 6 is for the LED. At this point we can write the actual program, that is servo1.write, and in parentheses we put the degree value we want our servo motor to move to. We do exactly the same thing for the second servo, and as you can see in this position, we'll set it to position 0. The degrees can range from 0 to 180. In this case, we set everything to 0 so that we bring everything back to the base position. If something is off, we adjust it by unscrewing the screw, fixing it, and screwing it back in. After that, we proceed with the actual program and start by setting all the servo motors to 0. After each command, we add a small delay just to avoid any issues. And at this point, we check that our script is correct. Servo 1 is not declared. And I believe it because I wrote iOS in lowercase. Okay, let's see if it works now. Perfect. Now, if you too are using a Chinese Arduino clone, there's a good chance your PC won't have the driver. So, if you're using a Chinese device, go here. I'll leave the link below in the description. Click on download here on CH340, install the drivers, restart your PC, and then your Arduino will connect without any problems. I connect my Arduino to my PC using the USB port. And then I will upload my completed sketch design. The moving head has both positions set to 0. So both the servo motor that controls the body and the servo motor that controls the I/O are set to 0. Let's do another small example. Instead of 0, now let's set it to the complete opposite. So 180 and 180. They should move to the exact opposite position. Let's check right away. Let's compile our sketch and upload it. As you may have noticed, I did a full rotation, but it can't quite reach it, so as a limit I would suggest setting, for example, 150 and 150. Let's try again. Let's reload our script. Now that we know all the positions of our servo motors, we can turn on the LED. It's not complicated. Just go back to void setup, write pin mode, assign it the pin where we've connected our LED, in my case pin number 6 if I remember correctly, yes, add a comma and set that pin as output. At this point, at the very beginning of the operational cycle, the integrated LED indicator should illuminate and turn on, so we meticulously write the command digital write 6 high into our code. And here too, we will carefully add a substantial 500 millisecond delay to ensure proper visibility and timing. At the precise conclusion of this cycle, however, the LED indicator should then completely turn off. For this, we will input digital write 6 low, and with that, our programming task for this segment is effectively done. In this particular case too, let's make sure to add a significant delay of 1.5 seconds, allowing ample time for observation. And at this crucial point, we are now ready to thoroughly compile our entire sketch once again and then proceed to upload it to the device. At the end of the cycle, it will turn off. It turned off, it turns back on and starts again. Now I'll write a small program so that it does a bit of choreography, and then I'll show it to you. Okay everyone, we have successfully completed our little trick. So we have performed a series of movements, starting with a precise zeroing procedure. Following this, we will verify that the light source effectively generates a distinct strobe effect. Subsequently, we will attempt an X-axis movement, which will be accompanied by another impressive strobe effect. After that, we will proceed with the Y-axis movement, and then to culminate our demonstration, we will execute a combination of LED activations and coordinated axis movements, all starting from an initial zeroing point. This will allow us to present a dynamic show featuring a sequence of distinct light effects, light effect 1 followed by light effect 2 and finally light effect 3. So let us now observe if everything functions as intended. It should indeed proceed without any hitches. I will now connect my USB port to the device and then upload the prepared sketch to the Arduino board. Once that is complete, we will disconnect the power supply from the PC and subsequently power the entire system using our reliable power bank. Y test, X test, conducted with the various strobe lights that frequently go off from time to time, creating a dynamic and visually stimulating environment. First light effect. Second light effect. Third light effect. And then the cycle starts over. Alright guys, I think that's it for today's video. Don't forget, buddy. Subscribe, look at what's here. Do you see all these curved scaffolds? And look at this one instead. This is the regular one. Well, now it's all hidden by the screen of my projector. But back here, I'm building a real miniature stage. There will even be a little robot that will put records in the middle there. But in the end, guys, this is all stuff you can see only if you subscribe to my channel. What the hell? Anyway, yeah, leave a like below if you enjoyed the video, and I'll see you in the next one. Bye, guys.